Ladies and gentlemen, I'm honored to be given this opportunity to present our research in the topic of effect of mixing ratio on capacity and stability of supercapacitor prepared from nanonickelite nickel cobalt hydroxide. There are many types of energy storage devices that use in several electric devices in this day, such as conventional battery and capacitor. So the battery store the electric energy by redox reaction of the electrode and the electrolyte, while capacitor store the electric energy by electrostatic effect of the dielectric materials. Supercapacitor is one kind of the electric energy storage device that store the energy with both mechanisms from the battery and capacitor. The performance of the energy and power density are improved to higher by both mechanisms. Due to the supercapacitor store the energy by both mechanisms, they can divide it into two types of supercapacitor. First, electric double layer capacitor or EDLC. They store the electric energy by electrostatic with the ion in the electrolyte. Almost the material of this type is carbon materials, such as the activated carbon nanotube, and graphene. The another one is the pseudocapacitor. This type stores the electric energy by redox reaction of active materials when the electrode charged and discharged. Almost materials are transition metal oxides and conductive polymer. Due to the EDLC type have some weakness, the efficiency is limited by surface area of material. That result in the EDLC type exhibit lower specific capacitance than pseudocapacitor. However, pseudocapacitor quite have low psychic stability. It is interesting to develop for higher performance for pseudocapacitor. Nickel and cobalt are interesting materials to use as active materials for pseudocapacitor because both metals show high theoretical specific capacitance and they have a long life cycle. And moreover, they have other great properties. Using both of materials as metal composite can improve the performance together, and maybe they can show synergistic effect for high-performance pseudocapacitor. Therefore, this research is conducted for develop high-performance pseudocapacitor from nickel and cobalt by using phase shield method, and follow up the effect of the ratio between nickel and cobalt on the electrochemical properties for high-performance pseudocapacitor. For the methodology, the mixed nickel-cobalt hydroxides were synthesized by facial hydrothermal treatment at 140 degrees Celsius for 14 hours. The nickel nitrate and cobalt nitrate were reduced by hexamethylene and used sodium sulfate to control the morphology of the crystal. The active material after treatment was prepared as a working electrode by mixing with the PTFE and conductive carbon. The mixture was coated on the 1 cm² area of the carbon paper that used as the current collector. For the result in this research, the SEM micrograph of all ratios were investigated at 30,000 times. Nickel hydroxide exhibits nanoflake-like structure that assemble to the similar flower crystal, while the cobalt hydroxide show random nanoflake-like structure also. All mixed nickel cobalt hydroxide exhibit same nano-needle-like structure. The morphology is more become uniform as needle structure when the cobalt content increase. For the XRD results, the nickel and cobalt hydroxide are confirmed the crystal structure by XRD pattern. The XRD result of nickel hydroxide exhibit high crystallinity on the 001 plane at 12.7 of 2 theta degree, while the cobalt hydroxide exhibit 003 plane at 20.1 of 2 degrees theta. The all mixture of nickel and cobalt hydroxide exhibit the both peak of nickel and cobalt hydroxide. This result can be confirmed successful synthesis by hydrothermal treatment. We note sharp peak around 18 and 26 2 degrees theta are clay support state and carbon paper substrate. For the electrochemical property, the cyclic voltammetric curve of our ratio exhibit paradox peak. The result can be confirmed the redox reaction of the active materials with the electrolyte when working electrode was charged and discharged. Moreover, nickel cobalt hydroxide at 33% of the nickel and 67% of the cobalt exhibit largest curve areas. This result can be implied this ratio is optimum point of the nickel and cobalt content. This result shows this ratio have highest specific capacitance also. The result is corresponded with the GCD results. When calculated the specific capacitance from discharging time of the GCD curve, the optimum ratio shows highest specific capacitance at 602.1 farad per gram. When investigate the preservation at 10 amp per gram of the current density, the optimum ratio shows highest preservation percent at 62.9%. These results show that the high efficiency of the electrode at high power. When investigate on efficiency in long cycle, the area of the CV curve increased when used in a long time. The results show the activation of the materials. For cycle at 500 cycle, the specific capacitance increased to 214.5%. That means this material can improve the performance when we active more time. When we calculate the power and energy density from the optimum ratio electrode, the results show the high performance in power density and energy density when compared with the conventional battery and capacitor. For the conclusion of this research presents the facial method to synthesize the nano-needle-like of mixed nickel cobalt hydroxide with high performance, and the optimum ratio of nickel and cobalt is 33% of the nickel and 67% of the cobalt respectively. The working electrode of optimum ratio show high performance of the specific capacitance, and the material can activate to improve the electric performance when used in the long cycle. Moreover, the electrode show high power density and energy density for pseudocapacitor application. Is that all my presentation? Thank you.